Hey guys, my name is Ben, and today we're going to talk about localization in SwiftUI. We're going to look into how to test any languages and regions in seconds. First, a little bit about me. I'm from France, and I'm one of the senior software engineers here at ShopBack in Singapore. Today we're going to see what is localization and why it's important to consider it earlier into the development. Then we look into SwiftUI and how to take advantage of Xcode Preview to help you design and test any of your components. And finally, we look into automation testing and how to automatically test any of your codes for new regions. So, what is localization? As you may know, the App Store is available in 100 countries and regions and supports dozens of languages. To deliver the best app user experience across so many regions and languages, it's important to adapt your app content to its audience. This can refer to translation, but not only. It can be about date formatting, calendars use, currencies, images, colors, and so on. It's key to prepare your app early on to launch on any of those new markets. If that sounds straightforward, it can actually become painful to get ready. Are you sure your login button will fit for any of available languages? Would it be cut off? Would it be too small? Does your development team have the resource and time to test each of them on any of available devices? And what if we change the copy tomorrow? After working 4 years in global e-commerce apps, localization content was really a tricky question for our team. How to implement, maintain, and test over time. Then SwiftUI came around. Let's see how we can localize an app in SwiftUI. So let's talk about SwiftUI and Xcode Preview. For this talk, I've created a sample app for runners to log their routes. Users can list and group their runs by categories and get more detail for any specific runs. It also includes a widget for runners to remember their favorite runs and always be ready for a new one. To focus on localization, dates are marked based on Singapore sceneries, but those runs and pictures are my own. Through this talk, our goal will be to prepare the app and its content for new regions by taking advantage of SwiftUI and the latest Xcode tools to make the testing through regions easier. Starting small, let's see first how to localize the copy. We used to have NS localization string passing different arguments like the key and the table to find a matching copy in your project. With SwiftUI, Apple introduced the localized string key, a struct to help bridge the gap and make the translation a bit easier. Nowadays, any SwiftUI component supporting localized string key will automatically look up for a translation by default. It means we can leave hard-coded copy in our SwiftUI view, and if it matches a localized string key, it will render the localization string based on this device locale. Diving deeper into text view, Apple introduced a lot more helper for simple but powerful localization features, including simple date formatter, but also the ability to use any other type of formatters we want. For most UI components, this could be enough, especially the date formats to avoid to have to create our own every time we want to display a date, although we still have the options to give a full formatter if we have to. Even better, we don't need to launch the app with each language to see how it looks. Using Xcode Preview and taking advantage of environment variables, we can start previewing how it will render straight from the beginning of the implementation. That is really amazing. So back to our running app. Let's apply this logic and see how it goes, starting first with localization key to cover most of our content. To start localizing SwiftUI view, we could do a bottom-up approach. To start from small components, climb back to each parent view, but today I'll go with the top-down approach, enforcing localized environments from the parent view and fix along the way to the child views. So let's see how it goes. This is the listing page. It's the starting screen of our app. It includes a title, a button to add new run, and a list of different sections. Each section represents a category of run. Each category contains a title as well as different cards. I've already adding a localizable string for English and French, so we can directly use environment variables with a new locale to see what is available in French. From here, we can see that the title and button are localized correctly. It means both arguments passed to each view match a key in the localizable file. However, the section titles are not yet reflected. Let's dive in to see why. For the section view, each card represents a running route. We can see that the title value is coming from the data structure section route. This data could come from the server side, if any, or a text input from the user. In this specific case, we don't need to change anything. It would be expected to be properly set from the data source itself. On the other hand, it seems the cards are yet to be localized to make sure the format is matching the device locale. So let's dive in further to support this. For each card, we have a title, here representing the run itself, a distance of the run, and a distance to the starting point. For those last two information, we can use a length formatter to make sure the card would reflect the right format for the region. At this moment, those information are computed properties. So let's implement a length formatter to improve this. The first thing we want to do is to create a length formatter and the right format we want to display. The second part is to replace each computed properties with our new values. It doesn't look much, but from now on, the card will automatically display the right format for any region or language given. Here is the detail page. It shows different information for a given run, including distances, time, and dates of run. Since we already covered some localized string key, we can see what is available in French language. To do so, I'll replace the locale to French one and see what's working. As you can see, most of the labels on the left are already supported. However, on the right, we can see that distance and times are still needs to be supported. To do so, and because text has different limitations, we'll have to create our own formatter as we did previously. We'll use a length formatter for all the distances and a date component formatter for all the times values. First, I'm creating a length formatter and a date component formatter that I create a specific format for each distance and time. I'll also let the constructor use both of the parameters with a default value that we'll be able to reuse later on. Finally, I'll update each computed properties with each formatter to make sure that it always reflects the right region. Great. This time we can see that each time values is correctly formatted, that the date was already supported, so we didn't have any problem with this. And finally, like both distances are formatted correctly. So what if we change for another region? Well, as you can see, some are applied, but not all. There is some limitation with the preview and any formatter we would have created when building our structure. We'll have to work around to make sure that time and distances and any other formatter we want to reuse will always be automatically translated when we want to preview, and not only when we launch the device. For the widgets, we have two UI versions, each one of them representing the user's favorite route. For the small version, we display the distance to the starting point. For the medium one, we display the title as well. Since the title is hard-coded and passed as a parameter to the view, the type is explicitly set as a string, which doesn't let the text view to look up for a matching localized string key. At the same time, since we display distance, we need to create yet another len formatter dedicated for our widgets. In this case, I'll use the entry provider data structure to create one formatter that will be reused for each widget. The first step is to create a len formatter for our entry provider. The second part is to adapt the card view to be able to use this len formatter as a parameter. Finally, we want to update the computed properties to reflect the right value using that formatter. We'll also update the title to be a localized string key to make sure that we look up for a translation. Okay, so the title is now translated correctly and the distance displays the right local measurement, but we still have this problem of preview where the environment local isn't applied to the len formatter. Here we see yards when the environment local displayed should be French one. So we still have a problem there. From our demo, we saw different limitations of Xcode Preview. The first one is around the string type. If a text can dynamically look up if a string pass can match a localized key, is not the case anymore as soon as we explicitly pass a string type. We also saw that the text can support a subject and a formatter as long as the subject is either an NS object or a reference convertible. Then the format should be able to handle it. However, most of type and classes aren't today supporting it. Time interval or double are one of those. Finally, most components only support default localization options. If you want a date formatter in a button, we'll have to create our own custom one. The last one is localized string key with format that we know from Swift. If SwiftUI and localized key string works pretty well together, it doesn't support localized string with format that we know of to pass different parameters. So any computed properties or computed string that we could use will have to work around as well. To work around those preview limitations, we have different angles that we could do to improve our code base. The first one is to use localized string key everywhere we can to enforce the type and make sure we always look up for a translation. The second one is use abstractions around classes and structs that are not yet available and enforcing local on this. It will allow us to create a wrapper and make sure that for any preview, we can make sure that the local and other environment variables are enforced so we can easily preview it at scale. Finally, we could use code generation to help us in this effort and generate strings, images, colors, and any other assets we would need to localize through our project. So let's see how it looks. Back to our detail screen. To make sure the environment variables are applied during the preview and not only when launching the app on simulator, like the local value we tried to pass so far, I'm going to create a wrapper around our formatters. To do so, I'll create a protocol that defines the minimum requirement for each formatter, and I will add a preview implementation to it. Let's start first with len formatter. So I've created a file and I'm going to create a protocol. I'm going to extend the foundation len formatter to implement this protocol. This is important because remember, we still want to use the foundation formatter when we launch the app. Then I'll create a preview implementation so we can reuse it. I'll do the same for the date component formatter, creating a new protocol, an extension for the foundation formatter, and an implementation for the preview. One thing to highlight is that we set the locale straight to the calendar, which is itself set to the formatter. This is how we make sure that the date component formatter will always have the right locale. Since we want to make it easier to reuse those preview formatter across the codebase, I'm going to create an extension to the preview provider protocol. This will allow other developers to quickly test their view using a centralized locale and formatters. The key here is to make sure those are computed properties so that any new preview would create a new instance. One last thing we can improve is access to translation. To make sure hard-coded strings are always looked up for matching keys, I'm going to create a data structure to represent all available translation. In the future, this code could be automatically generated to scale a side of the project. Great, so now we're ready to update our app, starting first with the detail page. The first part is to replace our formatters with new protocols. We'll keep the foundation formatter as default parameter in the constructor of our view. At the same time, we'll have to make small changes to adapt to our new protocols. With our new implementation, we don't need to use the same unit style anymore across the view. I'll adapt some computed properties for a better experience. One last change is to use our new translation structure across the view to make sure we always look up for localized string. This new structure makes it really easy for the development team to find available translation across the project. Finally, we can update the preview implementation to use our latest formatter. On the left, I keep the preview provider extension open so we can quickly change for a new locale and see it reflected on the right. If I use French, we can see that the whole screen is updated to French. Not only localized string, but also date, distance, space, and times. If I change back to EN, then it's all back to English. This is really great because now we can easily test any region and language in seconds. We can try Chinese and see what is working and what not, and if we want to try Korean and quickly see what would be the results. We can quickly preview our components to see what if a text is cut off, if a translation is missing, and anticipate any bugs. Alright, so if we sum it up, we've created some extensions and abstractions dedicated for our preview, and now we have a good template to preview any UI component for a new region or new language. Even though the preview has some limitation the way it applies the environment variables, we still manage to work around and make preview components easier for localization in the future. Overall, the development experience is a bit better. However, we still have to manually input locale or select each device we want to test. So let's see if there is a way to automate this. Since we want to test UI components and how they will render, we're going to dive into UI testing to capture how it will be. Great thing is Xcode tests allow you to attach a screenshot for any test. And this is going to be our goal. We're going to create different tests for each of our journey, capturing a screenshots to make sure that everything fits at the right place. The second part will be focused to automate our tests using latest Xcode tools, Xcode test plan. So let's dive in and create our first test. In my project, I've created a UI testing bundle to be able to test how the UI components will render. The goal here is not to test if the component is present or clickable in the screen. What we want though is an automated solution to preview each of our screens for a specific locale. To do so, we'll take advantage of UI automation testing. We'll implement different tests to capture screenshots while going through each journey of our app. The first thing we want to do is to create a function to attach a screenshot to each of our tests. Fortunately for us, Xcode Test Case has an API to include attachments. Alright, the first test we're going to code will be designed to go through the listing journey. Since the listing screen is also the landing screen at launch, we only need to launch the app to start it. To make sure it's the right screen, we'll detect if there is a card view existing in that screen. If the card view is detected, then we'll attach a screenshot. Here, card views refer to an accessibility identifier I added to my cards. It helps the test looking for specific UI components by the identifiers. In this test, the component is defined as a button because the navigation link is not available. SwiftUI views type are not directly exposed to Xcode test. I've used the accessibility inspector in Xcode to make sure the right type is detected. When launching the test, it seems like nothing much happened. However, the interesting part is if we go in our test results, we'll see that there is a screenshot attached to it. This is exactly what we wanted. We have a really simple test that we can quickly run to make sure that everything fits on the screen. Let's try now to do this for the detail page. We're going to create a new test to navigate to the detail screen and attach a screenshot the same way we did. The first part of the test is very similar to the previous journey, so we'll assume those elements are present and access them directly. This time, I've added an accessibility identifier to the scroll view instead. Same as before, it helps us making sure we're on the right screen. Finally, we can attach a screenshot to the result. Our second test is now ready, so we can launch the test and see how it looks. We'll see that we go to the listing page, click on a card, and go to the detail page successfully. If we go in our result, we'll see a new screenshot attached to the result. This is exactly what we wanted. We can now have a test to capture the listing page and one to capture the detail page. The first thing we can improve is create one test for both journeys, since the second test, the detail one, overlaps and captures the first one as well. So we can have one journey with two screenshots. If you are familiar with UI automation testing, so far it looks to be pretty trivial. It's true that we've captured screenshots of our app, but it only works for one region and one type of device. Here, the iPhone 11 and the system region in English. So how do we extend to other region and language to scale our effort? This is where we're gonna use Xcode Test Plan. Xcode Test Plan is a configuration file to manage how your tests are run. To convert an existing project to Xcode Test Plan, we need to open the schema, go under the test section, and convert it to use the test plan. In this example, I'll create a new test plan based on the existing schema, so it would be pre-configured. It is composed of two sections, a test one to enable and disable the test we want to run, and a configuration one. This is the part that is really interesting. It comes with sharing setting and a custom configuration that inherits from it. I'm going to enforce a localization environment to the first configuration that I'll dedicate to English and create a second configuration for the French one. If we run our previous test, we'll notice the app is launched twice. What is actually happening is that our test is run against each of the given configuration, one in English and one in French. If we go to our test result, we can see that all screenshots are now localized based on the region and language environments we set in our Xcode test plan configuration. If we go to the French configuration test, we can see text, distances, times and dates are all localized. And the same goes for the English configuration test. So with Xcode test plan, once we finish developing our app for a new market, we can just create a new configuration test for that specific region and make sure everything looks okay. Since it's still a test result format, it's also quite straightforward to connect it to your favorite continuous integration tools so that all your development team can keep an eye on it. Finally, it makes it super easy to prepare Appstore screenshots. The same way we did to preview our key journeys, we could extend to other features we want to publish on the App Store pages. Alright, we're almost there, but we haven't figured out how to test our app on multiple devices. Well, there is no way to do it from Xcode, but we can use Xcode build command line to test different destinations in parallel. So on the right side, I've got the iPhone 11 launched, and on the left side, I got an iPhone 8 available to test. What I'm going to do is launch the test of my project on both of those devices to make sure I know how it looks. Since we already set up Xcode test plan in our Xcode projects, Xcode build is gonna automatically pick it up and execute both configurations for both devices. So we're gonna save a lot of time there. Somehow, iPhone 11 starts first, but it doesn't really matter. What we want is just to see how the result would be when we're gonna preview it in Xcode. Great, so the test succeeded. What I'm going to do is to open the result in Xcode because it's just easier to preview everything. What we can see now is we have different sections for each devices we run the test against. And for each device, we have the English configuration test and the French one, which means now we can quickly preview each screen of our key journeys for different language and region, but also per devices. So for instance, here we could see the iPhone 8 might have problems to fit everything, so it may be something we want to look into in the future. One limitation though is we didn't get a chance to cover the widgets. Thing is, the widget itself is outside of the app, so we won't be able to use UI automation testing to get access to it the same way we did for other journeys. We could try to work around creating a wrapper with a specific view to preview it within the app, but that might sound overkill at the moment. In conclusion, through this talk, we discussed about the importance of localizing our app, making sure that we deliver the best user experience for any users, regardless of countries, regions, or languages. SwiftUI definitely brings a lot to the table to make development easier in this aspect. With the ability to pass environment variable when previewing UI components, we are able to support new regions in less efforts. Even though there are some limitations with the preview, we still manage to work around those and make development life easier. Finally, we created different tests to cover each of our app journey, making sure that we can capture how the components will render on any device. Using Xcode test plan, we were able to create different configurations for each region that is key to us. Moving forward, we'll be able to extend our projects to new countries while ensuring quality of supported one with automation testing. Alright, Thanks everyone for listening to my talk. I hope now localization is something you will look forward to work on. If you have any questions, you can find me on Twitter at Benoit_Pasquier_ or on my website benoitpasquier.com, where I mostly blog about Swift and iOS. Finally, I would like to thank iOS Conf and the organization team to still manage to make this edition happen. So thank you guys and see you all around.